Section 1.7, prime numbers and factoring. Just what are factors? Well, they're numbers that divide evenly into a given number, meaning that they have no remainder when divided. An example would be the number 6. The factors of 6 are 1, 2, 3, and 6, meaning that if you would divide each one of those into 6, you would have no remainder left over. Let's try an example. Find all the factors of the number 40. The easiest way to probably do it would be to figure out what times what will equal 40. Let's start with 1. 1 will always work. 1 times 40, those are two factors. Let's go to the next number, 2. 2 works as well. 2 times 20, so 2 and 20 are other factors. 3 does not work, but 4 does. 4 times 10, so those are other factors. And then finally, 5. 5 works. 5 times 8, and there are no factors in between 5 and 8 that go into 40 evenly. If we wanted to write it out as a complete list, the factors of 40 would be 1, 2, 4, 5, 8, 10, 20, and 40. Okay, let's talk now about prime numbers. Prime numbers are defined as numbers whose only whole number factors are 1 and the number itself. The numbers, or the factors, I should say, must be distinct, which means that the number 1 is not a prime number, believe it or not, because the number 1 only has one factor. Prime numbers have exactly two factors, 1 and itself. So what do you think is the smallest prime number? Well, it's actually the number 2. If we go in order, 2, 3, 5, 7, 11, 13, and so on is the list of prime numbers. Please note that the number 2 is the only even prime number. The last concept for section 1.7 involves prime factorization, aka factor trees. Yay! Okay, prime factorization is simply the expression of a number as a product, meaning multiplication, of its prime factors. In the next slide, I'm going to explain the difference between the factors of a number versus the prime factorization of a number. Okay, let's talk about the factors of 60. The factors of 60 are 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, and 6 and 10. In terms of the prime factorization of 60, let's set up a factor tree. So you're going to have a tree. Let me show you what it looks like. Okay, that's your entire tree. But let's start with 60. Think of two numbers that 60 can be broken into in terms of division or multiplication. For example, 10 times 6 works. You can choose any two factors that multiply to 60 that you want. Now, 10 and 6 are both non-prime numbers, so you can break those down further. Let's start with 10. 10 breaks into 2 times 5, and 6 breaks into 2 times 3, all of which are prime numbers. And notice that I circled them. I think it's a good idea just so that you don't forget any, and that you remind yourself when to stop. Okay, if we write them in ascending order, we have 2 times 2 times 3 times 5. Or, take it one step further, 2 squared times 3 times 5. Just to show you another way of breaking down the factor tree for the number 60, I chose 3 and 20 this time instead of 10 and 6. 3 is prime, so I circled it, but 20 can be further broken down. I broke 20 down into 4 times 5. You could do 2 times 10. It doesn't matter. 5 is prime, so I circled it, but 4 can be broken down further into 2 times 2. So if we look at the entire tree, we have 2, 2, 3, and 5, the same exact factors that you saw when I broke it into 10 times 6. It does not matter, you will end up with the same exact factors. And then we get 2 squared times 3 times 5. Okay, go ahead and try the prime factorization of the number 106. Notice that the number 106 is even. So what is it automatically divisible by? 2. Very good. So it goes in 2 times, and then we have 2 times 53. And that's actually the prime factorization. 53 is prime. We cannot break it down any further. Okay, last 2 examples. What is the prime factorization of the number 17? That's a trick question. 17 is actually a prime number. You wouldn't want to break it into 1 times 17. You don't want to use 1 because remember, 1 is not a prime number. So you would simply say prime. That's your final answer. Okay, let's try one more. 160. Go ahead and do a factor tree of 160 to determine the prime factorization of the number. I'll give you a minute. I take that back. I'll give you about 5 to 10 seconds. Well, I broke it into 4 times 40, both of which further break down. 4 breaks into 2 times 2, both of which are prime, so I circled them. And then 40 breaks into 4 times 10, both of which can break down further. 4 breaks into 2 times 2, both of which are prime. And 10 breaks into 2 times 5, both of which are prime. So we have 2 times 2 times 2 times 2 times 2 times 5, or 2 to the 5th times 5. No matter which 2 numbers you broke 160 into, you should end up with the same exact prime factors as me.